Let x is normally distributed random variable mean mu and variance sigma square, then the probability density function is given by f of x, x is given by 1 by root 2 pi sigma e to the power of minus x minus mu whole square by 2 sigma square. What is the mean expected values of x mu 1 dash, this is equal to integration minus infinity to plus infinity x f x x dx. So, this is the formula we know. So, this is nothing but integration minus infinity to plus infinity x f x x. So, then this is not this is equal to x, then we will put root 2 pi sigma e to the power of minus x minus mu whole square by 2 sigma square dx. So, now we have to do this integration. So, then first we will take the similar type of transformation here. So, this transformation is here, where this transformation, first we will take the transformation z is equal to x minus mu by sigma. So, which is equal to, first take this transformation z is equal to x minus mu by sigma. So, x is equal to sigma z plus mu and dx is equal to sigma dz. So, now at x goes to minus infinity, z also goes to minus infinity because sigma is positive. So, this is in minus infinity to plus infinity, z goes to x goes to infinity, then z goes to infinity also. Then what is x? X is nothing but sigma z plus mu and 1 by root 2 pi sigma is constant and e to the power of minus x minus mu by sigma is z. So, x minus mu whole square by sigma square is minus z square by 2 then dz. So, this is sigma dz. So, sigma dz. So, this sigma cancelled here. Now, what we found? We have to find these things. So, it is nothing but 1 by root 2 pi sigma into, so this is 1 by root 2 pi integration minus infinity to plus infinity sigma z. So, sigma outside sigma, this is sigma by root 2 pi z e to the power of minus z square by 2 dz plus the remaining is that minus infinity to plus infinity mu by, so just writing like this, mu into minus infinity to plus infinity 1 by root 2 pi e to the power of minus z square by 2 dz. So, now what will be the, so this is the simplification what we found, because it is sigma z plus mu. So, sigma into z e to the power of minus z square by 2 dz minus infinity to plus infinity 1 by root 2 pi. Now, this is, you can see that this is a, because it is a even function and this is a odd function. So, odd into even is nothing but odd function. So, that is why it is a odd function, and for this odd function we discussed that for this odd function what will happen, that this will be is equal to 0. For this odd function this integration minus infinity plus infinity x dx will be is equal to 0. So, so what we found, this value will be 0 and the what will be the value for this function. So, let us see that what will be the value, because we have already computed that whenever x is normal mu sigma square and the f x is density function, minus infinity to plus infinity f x x dx is equal to 1, which implies minus infinity to plus infinity f x x is 1 by root 2 pi sigma e to the power of minus x minus mu whole square by 2 sigma square dx is equal to 1. Now, note that this is true for any mu is real number and sigma is greater than 0, any value of sigma. So, if you take mu is equal to 0 and sigma is equal to 1, in that case also it will be true, and in that case we will find 1 by root 2 pi e to the power of minus x square by 2 dx, this is equal to 1. So, it is nothing but the density of the standard normal variate. So, here you can see that this is minus infinity to plus infinity 1 by root 2 pi e to the power minus z square by 2 dz. So, this way, that is why this value will be is equal to 1. Hence, this is nothing but mu into 1, this is mu. So, this value is mu. So, for x is normal mu sigma square, expected values of x is nothing but the mu. So, mu is the parameter, that is not nothing but the, that is the mean of this random variable, Next, we will find the variance of this random variable. So, we will use because of the convenience, most of the time we use the variance formula. You can remember that we use that variance formula, sigma square x is nothing but variance of x. We use expected values of x minus mu whole square, mu 1 dash. So, here actually mu 1 dash is nothing but mu, we found that this parameter. So, this is nothing but mu 2 dash minus mu 1 dash whole square. So, either you can find mu 2 dash and then you subtract it like that, but for because this density function it contains like x minus mu whole square, this kind of term. So, that is why maybe it will be convenient to find using this formula directly. So, let us find out that. So, sigma square x, that is variance of x, is nothing but expected values of x minus mu 1 dash whole square. Now, mu 1 dash is mu, we have already found that. Now, we want to find this is nothing but expected values of x minus mu whole square. So, how by what is the formula? It is nothing but minus infinity to plus infinity x minus mu whole square f x x dx. So, this is nothing but minus infinity to plus infinity x minus mu whole square 1 by root 2 pi sigma. This is the density function I am writing, e to the power of minus x minus mu whole square by 2 sigma square dx. So, it may be helpful. Let us see. If it is not helpful, then we will do the previous formula. This first we will find mu 2 dash, because in the density function also this x minus mu whole square there. That is why I thought that this integration may be directly, if you can find, this may be helpful. So, let us do this same transformation again. This transformation z is equal to x minus mu by sigma, then which implies x is equal to sigma z plus mu. So, that we will take, and dx is equal to sigma dz. So, this is equal to minus infinity to plus infinity, because z goes to sigma is a positive number. So, x goes to infinity, z goes to minus infinity, z goes to minus infinity, x goes to infinity, then z goes to also infinity. Now, x minus mu whole square. So, x minus mu is nothing but sigma z. So, x minus mu whole square is nothing but sigma square z square. So, this is nothing but sigma square z square 1 by root 2 pi sigma, as it is 1 by root 2 pi sigma e to the power of minus sigma x minus mu by sigma is z square by 2, and then z square by 2, and then dx is equal to sigma dz. So, this sigma and sigma, it is cancelled. So, then what we found, it is nothing but sigma square into sigma square by root 2 pi minus infinity to plus infinity z square e to the power of minus z square by 2 dz. So, this is we found sigma square by root 2 pi, this e to the power minus infinity to plus infinity z square e to the power of minus z square by 2 dz. Now, we want to find the value of this integral. What will be the value? Let us find out that. So, minus infinity to plus infinity z square e to the power of minus z square by 2 dz. Now, it is a, you can see that this is an even function, this is also even function. So, multiplication it will be even function. So, this will be nothing but 2 into 0 to infinity z square e to the power of minus z square by, so it will be minus z square e to the power of minus z square by 2 dz, z square by 2 dz. Now, how we will do this integration? Now, again we will use this gamma function, help of gamma. So, gamma alpha is nothing but 0 to infinity x to the power alpha minus 1 e to the power of minus x dx. So, now it is here you can see that e to the power of minus z square by 2 is there. So, we will put we will take this. So, also all this formula we know, gamma alpha plus 1 is equal to alpha gamma alpha, and also for L is integer natural number, then gamma L plus 1 is equal to nothing but L factorial, also gamma half is equal to root pi. So, those result we will use this. So, now we will use this here. So, now for getting in a gamma function form, what we will take? We will take the transformation z square by 2, this is equal to t, we will take this transformation. So, then because it is 0 to infinity, z square is equal to will be 2t, and then z 2t. So, z will be root over of 2t. So, dz will be root over of 2e by 2 root t and dt. So, then this is 1 by root 2. So, this is 1 by root 2 t and this is dt. So, that is I think this is fine. Now, we will put and also the limit does not change, z goes to 0, t goes to 0, z goes to infinity, t goes to infinity. So, this is 2 into 0 to infinity. Now, z square is equal to 2t. So, that is why, because here from here z square is equal to 2t, this is nothing but 2t e to the power of minus z square by 2, this is minus t, and then dz is equal to 1 by root 2t, 1 by root over of 2t and then dt. So, that is the integration we are finding. So, now you can see that this is coming as a gamma function form e to the power minus t only. Now, here 2, this is 2 into 2 by root 2, this is 2 root 2, 2 root 2. So, root 2 and then this is nothing but 0 to infinity t by, so t into 1 minus 1 by 2. So, this is 1 by 2. So, this is nothing but t is nothing but 1. So, what we have to find something minus 1, this is 2 1 by 2, because t by root 2 root tt root t. So, this is nothing but t 1 by 2 e to the power of minus t dt. So, this we have to write in a something alpha minus 1 form. So, this is 2 root 2 into 0 to infinity t to the power half, we can write t to the power 3 by 2 minus 1. So, then it will be in this form. So, this is e to the power of minus t dt. So, now you compare with this gamma function, then this is nothing but gamma 3 by 2. So, this is 2 root 2 into gamma 3 by 2, 3 by 2. Now, we will use this formula, gamma alpha plus 1 is equal to alpha gamma alpha, 3 by 2 can be written as 1 plus 1 by 2. So, that is why 2 root 2 into 1 by 2 gamma 1 by 2, because alpha is equal to 3 by 2. So, alpha plus 1, so alpha is equal to suppose 1 by 2, alpha plus 1 is equal to 3 by 2. So, gamma alpha plus 1 is equal to alpha gamma alpha. So, gamma 3 by 2 is nothing but 1 by 2 gamma 1 by 2. So, that we have used here. So, 1 by 2. So, then this is cancelled and root 2 gamma 1 by 2. So, then it is gamma half is equal to root pi. So, this is nothing but root over of 2 pi, root over of 2 pi. Hence, you see that from here this value we have computed here, this is nothing but root over of 2 pi. So, this is nothing but sigma square by root over of 2 pi into this value we computed just now, it is root over of 2 pi, this is nothing but sigma square. So, hence we learn this normal distribution function, they are probability density function, and we check that this it is a density function, it is taking 1, and also we have found their mean variance. The parameter mu and sigma square is very much significance of these parameters are mu is nothing but the mean of this random variable and the sigma square is nothing but the variance of this random variable. Next, we will discuss some of the properties of the, this is very important, some important properties of the random variable. Let us discuss some application of the normal distribution. There are many applications of normal distribution. Most of the data set we found in the nature follows normal distribution. For example, if you find the height, if you find and you see the distribution of the height, it looks like that some frequency of the probability of the, it is less than suppose 5 feet or less height, it will be frequency will be less. When higher height also, it will be like greater than 6 feet, then it will be frequency will be probability will be less, but in the middle like it may be 5.5, 5.7, this height will be more number of proportion of the people here. So, this looks like it is like increasing then decreasing symmetry around some point, and similarly if you IQ graph, then shoe size, then the birth weight, income distribution, technical stock market and student report, like usually if you do the grading of the student, if you want to see their performance with respect to their marks, then you will see that it will be also whenever data is large, it will follow a normal distribution. So, it is very important because most of the distribution encounter in practice, such as Poisson distribution, binomial distribution, hypergeometric distribution, or an exponential. Many of the distribution can be approximated by a normal distribution. Even if a variable is not normally distributed, it can found that often be transformed into a normal form through a simple transformation. Additionally, many distribution of sample statistics, for example, later on we will discuss the sampling distribution in the statistical inference, it will be very important. So, like sampling distribution, like what will be the distribution of the x bar, what will be the distribution of the sample variance S square. These are all actually the most of the sample S square will be square of the normal distribution, that is known as chi-square distribution. Sample mean, so these are all normally distributed random variable whenever sample sizes are large. Now, one of the important properties is that if x1, x2, xn be independently normal distributed random variable, then their linear combination also will be a normally distributed random variable. So, let us write down that let x1, x2, xn be independent and independent random variables with each xi has normal distribution mean mu I, variance sigma square. Now, if you take a sum of the linear combinations like y is equal to some alpha 1 x1 plus alpha 2 x2 plus some number maybe alpha n xn. So, here n number of random variable we have taken. So, independent be independent random variables. Now, it will also have a normal distribution, some mean mu y and variance sigma square of y. So, that proof actually now we will not learn, later we will learn some of the other important things. So, it is called a moment generating function. Using moment generating function, it is nothing but the transformation of random variable. We will learn that how to find the distribution of a transformation of random variable, then we can find this distribution. Now, if you assume that linear combination as a normal distribution, then mu y, mean mu y and variance sigma square y, then you can easily find this mean, what will be the mean and what will be the sigma square, because what will be the mean of this y? Mu of y is nothing but expected values of y. Now, expected values of y is nothing but alpha 1 x1 plus alpha 2 x2 plus alpha n xn. We have discussed that some of the properties of it is a linear transformation exponential. This is nothing but expected value is a linear transformation. So, this can be written as expected values of x1 plus alpha 2 expected values of x2 plus alpha n expected values of xn. So, then because expected value of x1, expected value of x2 we already know, because it is a xi is normally distributed. So, expected values of xi is nothing but mu y and variance of parameter mu y. So, that expected value of xi and variance of a sigma square xi is nothing but sigma square. So, that we will use here. So, this is alpha 1 into mu 1 plus alpha 2 into mu 2 plus alpha n is equal into mu n. So, this is the mean of this normal distribution. Now, what will be the variance of this normal distribution y? Sigma square y will be variance of y. This is nothing but variance of alpha 1 x1 plus alpha 2 x2 plus alpha n xn. So, it is another property that variance actually, because it is an independent random variable, we can write alpha 1 x1 plus variance of alpha 2 x2 plus alpha variance of alpha n xn, because they are independently distributed random variable, that is why you can write. Otherwise, there will be some covariance terms, but that we will discuss in whenever we will learn the bivariate random variable. But here, because of independent, this is the formula. Now, this is now we have already discussed some variance of a c into some random variable, some constant. This will be coming out as a square of variance of x1 plus alpha 2 square variance of x2 plus alpha n square variance of xn. So, now this is variance of x1 is nothing but sigma square. So, this is alpha 1 square sigma 1 square plus alpha 2 square sigma 2 square plus alpha n square. So, this is alpha n square sigma n square. So, this is the variance of this random variable. This is one properties. Now, from these properties we can this is a general property. Next, it is very important. So, next property is that if x is a normal mu, mean mu and variance sigma square, then if you take this transformation z is equal to x minus mu by sigma, then z follows a standard normal distribution. That means standard normal means, so expected values of z will be nothing but 0 and variance of z will be nothing but 1. So, z is nothing but normal 0 1. So, that we will see that. So, because it is also, if you take x is a, if x is normal mu sigma square. So, take transformation z is equal to x minus mu by sigma. So, it is also a linear transformation because it is 1 by sigma x minus mu by sigma, it is a linear transformation. So, that we discussed that any linear transformation of a normal distribution, it is again a normal distribution. Now, we have to find it is again a normal distribution. Now, we want to find the what will be the mean and variance. So, it will be normal distribution mu z and variance of z, this is, so mu z and sigma square z. Now, we want to find what will be the mean of this random variable and variance of this random variable. So, mean of this random variable mu z is nothing but expected values of z. So, this is expected values of x minus mu by sigma. So, because it is sigma is a constant, 1 by x sigma into expected values of x minus mu. Now, expected values of x minus mu is nothing but expected values of x minus expected values of mu. Now, mu is a constant. So, we have already discussed, and expected value of x is nothing but mean of this random variable, this is nothing but mu, and mu is a constant random variable. So, this is again mu. So, this is nothing but 0. So, now what will be the sigma square z, what will be the variance of z. So, this is variance of z, this is nothing but variance of x minus mu by sigma. Now, this is sigma is a constant. So, it will be, we have already discussed, it will be 1 by sigma square variance of x minus mu. So, now it is another exercise, you may say that, see that for any random variable, another properties for any random variable x, if you take this transformation x plus c is a constant, this variance does not change for any c in the real number r. For any c in the real number r, this variance does not, variance of x plus c is nothing but variance of x. So, that is why mu is a real number. So, it is x minus c. So, this is nothing but variance of x by sigma square. Now, what is the variance of x? So, variance of x is nothing but this parameter sigma square. So, this is the sigma square by sigma square, this is equal to 1. So, this z, if you take this transformation, so if you take z is equal to x minus mu by sigma, it is nothing but normal 0 1. So, this is nothing but the standard normal variate. Now, suppose you want to find the probability distribution function or any probability related to a normal distribution function, because the integration is not tractable. For example, suppose you want to find, suppose let x is normal mu sigma square. Now, you want to find a probability that x is greater than C1 less than equal to C2. So, what will be the probability? This probability will be nothing but integration C1 to C2 fxx dx. So, C1 and C2 can be anything, like C1 maybe we can take minus infinitive, C2 can be, we can take any of the values real number or 10 to infinitive also, one of the things may be real number. So, now both can be taken be real number, any values like. So, then this probability will be nothing but minus C1 to C2 1 by root 2 pi sigma, because this is the density function, x minus mu 1 by x minus mu whole square by 2 sigma square dx. Now, you can see that this is intractable, because it is not tractable, because this integration it is not straightforward to do, we cannot find this integration. So, that is why up to this we can do, after that we cannot find any close to some value real number. So, we can either do a numerically, or we can take a transformation. Suppose if we take this transformation, z is equal to x minus mu by sigma. So, we know that this, if you take the transformation z is equal to x minus mu by sigma, it has a normal 0 1. So, here you can take this transformation. So, x is equal to sigma z plus mu. So, dx is equal to sigma dz. Then what is the limit it will change? So, limit it will change like it is nothing but, so this is nothing but whenever x1 is c1, so this is nothing but z is c1 minus mu by sigma, and whenever x is c2, so then this is nothing but c2 minus mu by sigma. So, here it is assumption is that c1 is less than c2, and then this is 1 by root 2 pi sigma e to the power of minus z square by 2 sigma dz. So, sigma is cancelled. So, then we have to find this integration. So, this is nothing but c1 minus mu by sigma to c2 minus mu by sigma 1 by root 2 pi e to the power of minus z square by 2 dz. So, this is actually density of a standard normal variate.